I'm going to bubble my critical values and see if I'm actually going to include them. Oh, notice, interesting. See that equal to sign on the bottom? That means I'm going to include my critical values. They are equal to, bubbled in. We didn't do that on this one because it didn't have the equal to. Let's see, okay, so this section we said no, so we're not going to fill it in. This section was also a no. Oh, but this section was a yes, so let's go ahead and fill that in. And the last section was a no. Huh. So let's go ahead and write the solution in interval notation. So starting from the left, we start at -3, and oh, that's weird. We end at -3. Well, we can still write that in interval notation. It looks kind of funky, but start at -3 and end at -3. There we go. Kind of funny. Union, start at 0 and include 0, and we go until 2, and we include 2. Okay, so I really like the charts. They help keep things neat and concise, so I'd really highly encourage you to make use of them. But please always point out your critical values and the test points that you use. Okay, next page. Bumping up the challenge a little. Okay, so notice we now have a fraction. So that makes things a little more interesting when we have a fraction because we bring in the possibility of having our answer or critical value make something undefined. Okay, so that's the challenge we bring in when we bring in fractions. But sort of the same idea happens. We want to set this equal to 0 and then factor. Well, at the moment it's equal to 1, or it's not set to 0. We have the 1 here. So we're going to move 1 to the other side. And when I do that, I get 2 over x minus 1 minus 1 is less than or equal to 0. Now, this is where it's interesting. I want this to be one fraction. So let me write that. We want one fraction. We want one fraction. This, my friends, is not one fraction. So we're going to use the building up property to make this one fraction. So in order to subtract fractions, they need the same denominator. I'm going to use x minus 1 as the common denominator, so I'll multiply x minus 1 to the bottom and to the top, the building up property, which means, I'm going to jot this out over here, I get 2 minus x minus 1, and when I subtract them, it's all over x minus 1, and that is less than or equal to 0. Let me go ahead and draw a line down here. All right, and subtracting those, that is going to come out to be 2 minus x. Well, that doesn't subtract, so then 2 minus -1, it's going to be 2 plus 1. So it's going to be 3. So I have 3 minus x all over x minus 1 is less than or equal to 0. And there we have the single fraction that we are going to go ahead and use. That was our goal. So now we need to pick off our critical values from this. Similar idea as what we've been doing before. We take all the factors. So notice this is a binomial, that's a binomial. And we set them to 0 and solve. Okay, so critical values, let's see. So we have 3 minus x equals 0, and 3 minus 1 equals 0. Oh, sorry, x minus 1 equals 0. Solving for x, we get 3 equals x, and x equals 1. So those are our critical values. But we need to be careful. See this x minus 1? That came from the denominator. If I let my value be 1, and I plug that in here, I'm going to get 0 in the denominator, which is undefined. That is a no-can-do moment. Okay, so if you want to remind yourself that this is from the denominator, you can do a star or something to remind yourself. Okay, because we can't let 1 be part of our solution. He causes some bad problems. He's a problem number. Okay, but same thing. Let's go ahead and set up our chart. we have two critical values, 1 and 3. So it's just splitting our box into 3 columns. The factors I have are 3 minus x and x minus 1. Okay, so my test point box, that factor, this factor. When we're done with the factors, we check the sign. And then we put our end goal at the very end of our chart. What is our end goal? Well, our end goal is to see if our sign is less than or equal to 0. Let's go ahead and put that. Is it less than or equal to 0? Well, let's pick our test points. If I can pick 0, I'm gonna pick 0. Something between 1 and 3. How about 2? Something greater than 3? I'll go with 10, my favorite. Okay, let's go ahead. Try test those points. See what you get. All right, checking in. So 3 minus 0, that's going to be a positive. 0 minus 1, oh, that's a negative. Positive times negative, that's going to be a negative. So my end sign, is that less than or equal to 0? Haha, yes. Yes, ma'am. Okay, let's check the next one. Test point is 2. So 3 minus 2, that's going to be positive. Ooh, got the bug. Away. Okay. Testing 2. So 3 minus 2 is positive. 2 minus 1 is also positive. So positive and positive is positive. Is that less than or equal to 0? No. All right, checking the last one. 10. 3 minus 10, ooh, that's going to be negative. 10 plus 1, oh, that's positive. The sign, negative times positive is going to be a negative. So is this less than or equal to 0? The answer is yes. Okay, so we're going to go ahead and fill these in. So, remember to bubble off your critical values, but we need to be careful here. Why? Because we're working with a fraction. Okay, fractions are testy little ones. Our critical value 1 came from the denominator. So even though our sign says less than or equal to, we can't allow positive 1 to be part of our solution. So we're not going to fill in this bubble because it came from our denominator. But we're going to fill in the 3 because it's allowed to be equal to 0 and it just came from the numerator. There's no problem having 0 in the top. Okay, so 3 we're going to be able to fill in because it came from the top. 1 we're not going to be able to fill in because he came from the denominator. Okay, and then let's go ahead. This section worked. It was a yes. This section did not work, so we're not going to fill it in. And this section worked, so we're going to fill that in. Lastly, let's do the interval notation. Starting from negative infinity, we go until 1, but we don't include 1, so open parentheses. Union, we include 3, and we go until positive infinity. Okay, so the main new addition to this was we needed to add the fractions into one fraction. Okay, so that's the thing that you need to remember. It needs to be set to 0, needs to be one fraction. Okay? We want one fraction. So with that mindset, let's look at C. This is obviously not one fraction. You might be tempted to multiply through by the LCD to wipe out the fractions, but we can't actually do that because we don't know what x value is. I should have mentioned that previously. We cannot get rid of the fractions here like we can normally do with equations. The reason why we can't do that with inequalities, and we can with equations, is because with an inequality, remember, we have that little sort of problem that when we multiply or divide by a negative, our sign flips. So if I was to multiply this by x minus 1, as an LCD or something to both sides. If I did that, I do not know if I'm supposed to be flipping my sign or keeping my sign in the same place. I don't know the answer because I don't know what x is. So because of that unknown, and that we don't know if x is a positive or negative quantity, we have to keep the fractions. Okay? So we cannot just get rid of the fractions like we could normally do with equations. We have to keep them, sadly. Alrighty, so let's move everyone over to one side. And I'm going to put the 1 over 1, and then minus the 2 over x plus 1, and that's greater than 0. Okay, so we have 3 fractions and they need to have the same denominator. What would the LCD be? Let's see, looking at the denominators, the LCD is going to be x minus 1 and x plus 1. So we're going to go ahead and do the building up property for that for all of them. So that's going to be multiplying by x plus 1, x plus 1. For this one, multiply x plus 1, x minus 1, x plus 1, x minus 1. Building up property. X minus 1, x minus 1. Whew, that's a lot of writing. Am I going to run out of space? Hopefully not. All right, let's see. So 2 times x plus 1. I'm just going to clean this up. Plus x plus 1, x minus 1, minus 2 times x minus 1. And that's all over the one big fraction of x plus 1, x minus 1. And we want that greater than 0. Okay, let's go ahead and use the distribution property to multiply these out. 2x plus 2 plus, foiling this out, x squared. Ooh, those are the conjugates. Gives me x squared minus 1. Multiplying that out, minus 2x plus 2. All over x plus 1 times x minus 1 greater than 0. Let's see, like terms. The x, those guys cancel. And the other ones stay the same, so we have on the top x squared, 2 minus 1 is going to be 1, and then plus 2 is going to be 3. So plus 3 all over x plus 1, x minus 1 greater than 0. All right, so now we have everything set up to solve for our critical values. We have the one fraction set to 0. So for my critical values, sorry, I'm going to squish this in here. Set everything equal to 0, so x plus 1. Ooh, let me give myself a little more space here. Let me just white this out so I can give myself more space. What was that? X squared plus 3? X plus 1, x minus 1, greater than 0. Okay, my critical values. So x squared plus 3, set that to 0. X plus 1, set that to 0. And x minus 1, set that to 0. Okay, so solving, x squared equals negative 3. Ooh. That's not going to have a solution. In fact, is there any number I could plug into the numerator that would make this turn into 0? No, there's no way to make this 0. So in fact, this doesn't give me a critical value, so we're just going to leave it. No real solution. Okay, so no critical values from the top. Let's go ahead and get critical values from the bottom. And there we go. So I'm going to go ahead, plot our points, -1 and -1 and 1. Test point. And we could include the x squared plus 3 if we want to. We don't have to because it's always going to be positive. But Might as well, why not? X squared plus 3, even though it's always going to be positive. And then my other factors, my sign, and what do we want our end sign to be? We want it to be greater than 0. So is this greater than 0? Okay, go ahead, pause the video, find your test points, label them, and check to see what signs you get. Alright, so test point, let's do -10, 0, and 10. -10 squared plus 3, positive. -10 plus 1, negative. -10 minus 1, negative. So multiplying these together, I'm going to get a positive. And is that greater than 0? Yeah. Awesome. Okay, plugging that in. 0 squared plus 3, 0. 0 plus 1, positive. 0 minus 1, negative. I don't know why I put a 0 there. It's late. Okay, multiplying these all out, I get a negative. Is that greater than 0? No. And last one. 10 squared plus 3, positive. 10 plus 1, positive. 10 minus 1, negative. Now, if you want to write all these little mini calculations out on the side, you can. If you can do them in your head, also okay. Multiplying this all out, I get positive, positive. Oh wait, that's supposed to be a positive as well. Multiply it all together, I get a positive. So is this greater than 0? Yes. Okay, let's go ahead and fill in the intervals. Do I include and bubble in these? Well, in general, this says not equal to, so I'm not going to fill those in. And then let's fill in where my interval said yes. And there we go. Lastly, let's go ahead and do interval notation. So starting from -infinity, we go until -1. Don't include it. Start again at 1. And go till +infinity. All right, hitting the last stretch here. Awesome. Absolute value inequalities. Okay, so we've got double things going on here. We got the inequalities and we have absolute values. Okay, so there are two different absolute values that we work with. We work with the and, or we work with the or, and we split these up differently. So remember, the goal is to always get them out of the absolute value. First thing I want to do, though, is to make sure our absolute value is isolated and it's by itself. So let's check. Is there any number hanging out by the absolute value? For example, was there 2 multiplied to it or something? Or maybe a 2 being added to it? Nope, our absolute values are all by themselves, so that's good. So next thing we're going to do is split them. And you've hopefully seen this before, but I'm going to go ahead and grab a sticky note. This is an acronym I like to use to memorize how to split these. It's called GOAL. So G is for greater than, L is for less than. And this is talking about our absolute value. So if our absolute value is greater than, we're going to split it into an OR statement. O for OR. If our absolute value is a less than statement, we're going to split it into an AND statement. Okay, so let's see. For this one, our absolute value is less than 5, which means we're going to split it, L for less than, we're going to split it into an AND statement. So let's go ahead and do that. So we have 2x minus 3 is less than 5 and greater than 5. Greater than the -5. Okay, so that is an AND statement when it's squished together. And let's go ahead and solve this. Oh, we solved something similar to this previously. So we just have to isolate the x. So let's add 3 to both sides. Divide by 2 from both sides. -2 divided by 2, -1, less than x, less than 8 divided by 2, 4. All right, let's go ahead and graph the solution. Let's see, our boundaries are -1 and 4. We're not including them. And our answer is in the middle.